So today we are going to be talking about substitution elimination, and hopefully this will be review for you guys, okay? After this lesson, you will know the difference between consistent system and inconsistent. You'll be able to tell independent from dependent. You'll understand the solutions related to the graphs, and you'll know how to solve a system by using substitution or elimination. Okay, so the first things we want to talk about are consistent systems, and consistent systems have at least one solution. So basically they could have one solution, and that's if the variables don't zero out, and those would be intersecting lines like this, like intersecting lines to make one point. Or they could have the variables zero out, and then they could have infinitely many solutions. And when the variables zero out, that means there's no more variables, so you have a true or false statement. If you have a true statement like 0 equals 0, 3 equals 3, now we know that there's infinitely many solutions because these are coinciding lines, which means they're the same line. So basically laying on top of each other, right? And then over here, we talk about inconsistent. Now those would have no solution. And so again, we would have the variable zeroed out, but instead of a true statement, we would end up with a false statement like 3 equals 0, 5 equals 0, something like that. And these would be like parallel lines like this. Okay? So inconsistent is the no solution. So if you have at least one solution, it's consistent. If you only have one, it's independent. And if you have infinitely many, it's dependent. Okay. So the two ways that we can solve these equations, and please feel free to pause, go do these problems on your own, see how you do, because you should know how to do these problems. Okay, so I'm going to walk you through some steps, and I have the steps over here. If I don't refer to them all the time, those are the steps. So first we're going to pick one equation and get one variable alone. The cool thing about this system is we already have the t alone, okay? And that is usually the only time I ever use substitution is if I already have a variable alone. So as it is, I already have that variable alone. So I'm going to put a box around it, and that box just helps me. This little box just helps me know where that is, okay? And what it also does is it says for all the t's have the same value as 2r plus 3. So that's the expression that we're going to be able to substitute in for that variable. So the next step is to substitute that in. So we have 5r minus 4, and we substitute 2r plus 3 in for that t. Now what's cool about this is it's our goal to just get one variable because we know how to solve that. So now we're just going to use our algebra to solve this. But remember, if you have a negative number in front of a parenthesis, you need to take that negative number all the way through. So we'll have 5r minus 8r minus 12 equals 6, and so negative 3r minus 12 is equal to 6. So negative 3r, adding 12 to both sides, is equal to 18. Divide by negative 3, r is equal to negative 6. Now, you're going to get a solution because your variables didn't go out. But here's our solution. Our solution is a point, right? So we need to decide who's going to go first on our ordered pair. Well, it always goes alphabetical, so r would come before t, so we'll put the r here. The next thing we're going to do is we're going to use that value and go back into the box. So we take this value and we take it back up into the box, because we know to get t, we would take 2 times whatever the r value is and add 3. Well, the r value we got was negative 6. So t is equal to negative 12 plus 3, which is negative 9. And there's our one solution, which means it's consistent and independent. The system is consistent and independent. Okay, for the next example, unlike the last one, who had a variable alone, this one doesn't. But you can see that this has a coefficient of 2, this has a coefficient of negative 4, this has a coefficient of 3. In order to solve for those variables, we would probably get a fraction at the end. We might not, but we have a chance to get a fraction at the end. But this x does not have a coefficient, so we're going to go ahead and choose this equation and solve for x, or get x alone, by subtracting 3y. So we get x is equal to negative 3y plus 7. So here's our x alone, and so there's our box. So now, everywhere we had an x in the other equation, we could put negative 3y plus 7. So here's your x. So we're going to go 2 times our x value, which is negative 3y plus 7, minus 4y equals 24. You can see how we only have one type of variable now, so we're good to go. Distributing negative 6y plus 14 minus 4y equals 24. So we're going to have negative 10y plus 14 is equal to 24. Now, after we subtract 14 from both sides, we'll get negative 10y is equal to 10. And so our y is going to be a negative 1. Again, for x and y would be the second value. So we take this y back up into our box because we know to find x, we would have negative 3 times our y value, and we would add 7. So 3 plus 7 is going to be 10. And so again, we have one solution, which makes our system consistent and independent, which means our lines are crossing at one point and sharing one point. Most frequently, we use elimination because it's just a little bit more work to use substitution. So when we go to use elimination, we usually don't want fractions or decimals. We also want to line things up. So all our A's, our D's, our equal sign, and our constants are all kind of in a line. This is because I'm going to be adding straight down. Because if this right side has a value negative 1, so does all of this. So it's okay to add this to this side and this to that side because they're the same exact value. And that's the reasoning behind it. But why would we add those together? Well, the reason why is because we're going to use multiplication, if we need to make sure that one of the variables eliminates. So to eliminate, I need to have additive inverses. So if I have 9a, I need a negative 9a. So in order to do that, I use multiplication, which means I would multiply everything by 3. So I originally had 9a minus 3d equals 3. And now I have negative 9a plus 3d equals negative 3. And now when I add that up, yes, this does have opposites and makes a 0. But guess what? We zeroed out both variables. So now we need to decide if we have a true statement or a false statement. And 0 is definitely equal to 0, so this is true. And so when it's true, that means we're going to have infinitely many solutions. Because there's infinitely many points on a line. So we have one line that's going like this, basically, and another line that's laying right on top of it and sharing all of its points. And that's why we have infinitely many solutions. So this would be consistent and dependent. Okay, the next one, you guys, notice how we have fractions. Well, yuck, right? So we are going to get rid of those before we even start. And so if I have a 2 at the bottom and a 3 at the bottom, I can multiply everything by 2 and then multiply everything by 3, or I could just multiply everything by their product, which is 6. That's the lowest common multiple, right? So as we do that, this guy will be turning into a 3. 3 times 1 is 3, so 3x. This guy would be 2. 2 times 2 is 4y. And then 6 times 1 is 6. And then we go to the next one. We have a 4 on the bottom and a 3. Well, 4 times 3 is 12. So we'll go ahead and multiply by 12. Notice how I'm not doing the elimination yet. I'm just trying to fix my problems to have a little bit easier. So the 4s, this has a 4 in common, which leaves a 3. 3 times 3 is 9x. And then this would be 4 times negative 1, or negative 4y, is equal to 24. When we add those together, we're super excited because guess what? We already had opposites. So now we're going to have 12x is equal to 30, and we divide by 12, and we get x is equal to 5 halves. Well, 5 halves is a weird number, but it's a number, guys. That is our x. But we have to find y. So we're going to substitute this value back into either equation. Now, I'm not going to go back to here because that obviously had fractions. I'm going to go back to one of these, right? So I'm going to go 3 times my x plus 4y equals 6. And it doesn't matter which equation that you use. So I have 15 over 2 plus 4y equals 6. Again, a fraction. I don't like the fraction, so I'm going to get rid of it. You don't have to. So this would be 15 plus 8y is equal to 12. When I subtract 15, when we subtract 15, we're going to get 8y is equal to negative 3, which means our value is negative 3/8. And so that's, again, two lines crossing, independent, consistent and independent. Now, I'm hoping that you guys have push pause from all of these, but here's some more. When we're looking at this one, we're trying to figure out which ones to eliminate. It's a little harder to eliminate the 6 and 3, I think, or the 6 and the 9 in your head, maybe, but the 2 and the 3 should be pretty easy. It really doesn't matter which one that you do, as you will see soon, because you're going to get 18x minus 6y equals 33. And then you're going to get negative 18x. See? It actually eliminated both of them, which means that we're going to either have no solution or infinitely many solutions because we have eliminated the variable. And because this is equal to 65, this is a false statement. 0 is not 65, so there's no solution. So since there's no solution, we know that those lines were parallel, right? They were parallel. Okay, let's see this one. Well, there's that negative 2 and 3 again. You know what? When I see a problem and one of the variables has a negative and a positive, I usually try to get rid of that one because I don't want to mess around with negatives. Because I never subtract, I always multiply by negatives. So 15x minus 6y is equal to negative 57. And then 4x plus 6y is equal to 0. Yes. And then we get 19x is equal to negative 57. And so when we divide by 19, obviously that was 3 19s. So that's going to be x equals negative 3. So that's our x, and we just need a y. So we go back up to one of these equations. I'm going to pick this one. It doesn't matter which one you pick. 2 times our negative 3 plus 3y is equal to 0. Negative 6 plus 3y is equal to 0. And when you add 6 to both sides, you'll get 3y equals 6 or y equals 2. And there you go. It is going to be consistent and independent because these two lines are going to hit each other at a point. Okay, I hope that helped to remind you. Have a wonderful day.